Don't watch this video if you already think SQL window functions are complex to understand, because this is gonna be the easiest explanation of window functions you have ever seen. Just clear, simple logic using Postgres and the Chinook database. And we'll be breaking down row number, rank, lead, lag, and much more with the easiest explanation ever. Let's start with the row number function. We have one table in our database called as employee. Select star from employee. And these are the columns we can see: employee ID, last name, first name, title, reports to. Reports to column is the manager's ID, we can say. Means these employees report to these particular managers. And these are also the employee IDs, we can say. The manager's employee ID. And birth date, hire date, address, city, state, country, postal code, phone, fax, email. So these are all the columns that we have in employee table. Let's say you are a manager and you want to know which of your team members joined first. I mean, based on this hire date. So we will design a query that gives each manager their own ranking list based on this particular hire date column. It's like organizing kids by classroom and then ranking them by age inside each class. So to write that query, we can proceed like this. Select employee ID. We want the employee ID for each employee to be displayed, and first name. Let's only take the first name as of now, not the last name, and reports to. So this is the manager's employee ID. Reports to, comma. We want the hire date as well, comma. Row number. So we will be ranking each employee under each manager based on this row number or using this row number function. Row number over partition by reports to. So we'll be partitioning the whole data set based on this reports to column, which means we'll be grouping the data set or the table with these reports to column. I mean, for each manager, we'll be finding the employee details. So partition by reports to, and on which column we'll be ordering it based on the hire date. Reports to order by hire date. And we will be giving a alias name to this particular row number column as join order from employees. Employee. If we run this, so we are getting the employee IDs, first name, reports to, hire date, and join order. So let's come to this reports to column first. So we can see this reports to column has been grouped by. So reports to ID 1, which means the first manager has these two employees, employee ID 2 and employee ID 6. So based on this hire date, we are ranking these two employees as 1 and 2. So first or the lowest hire date here is 2002 May 1st, 0501, which means this is the first employee to join under this manager, and then the next employee, which is employee ID 6, Michael, and he has joined on 2003 October 17th. So this is the second employee. So the order join order is 2 here. In the same way, for the manager with employee ID as 2, the first employee is employee ID 3, and he has joined in 2002 April 1st, whose join order is 1 here because this is the lowest date between these three dates. So as we can see, only these three employees have joined under this manager ID 2. So this employee ID 3 is having the join order as 1. Employee ID 4 is having the join order as 2. Employee ID 5 is having the join order as 3 based on this particular hire date. In the same way, we can see for the manager ID 6 as well. It's 1 and 2. And there is one employee who doesn't have any manager as of now. We can see the value as null. For that null value also, we can see a join order has been generated. So this is how row number works. All right. Now that we have understood row number, now let's talk about two similar but very important Windows functions. That is rank and dense rank. Rank and dense rank. Let me explain with a simple story. Imagine you are working in the finance team at a music store, and your manager asks, "Can you find out which customers have spent the most with us?" This question can be solved using a simple query. So we have an invoice table here in our database. Select star from invoice, and our invoice table has invoice ID, customer ID, invoice date, billing address, billing city, billing state, billing country, billing postal code, and total. This total means the total amount spent by each customer based on each invoice. So let's write this query. Select customer ID, comma, total, comma, rank over order by total descending. And we'll be giving an alias name to this as spending rank from from invoice table. Let me run this. So before running this query, let's explain what this query does. So we are ranking customers based on the amount they spent for invoice from highest to lowest, which means we have used here order by total descending. We are ranking based on this particular sort order or based on this particular condition. Order by total descending means the customer or the invoice that is having the highest total will be ranked first. It will be rank 1. Then the other totals would be following that particular total, the highest total. Let's run this query now. If we can see, the highest total here is 25.86, for which the customer ID is 6. This particular customer has spent this much and is having the spending rank as 1. And we can see customer ID 26 has the spending or the total as 23.86, which is the second highest. So the spending rank here is 2. We can see here there are two similar ranks for two different customer IDs. So here is where it gets interesting. Suppose two customers have have the exact same invoice amount. Let's say it's 21.86. The ranks give both of them the same rank. Okay, which means our rank function gives or generates the same rank for both these customer IDs or both these invoices. But the next customer should get rank 4, right? Means the customer ID 7 should get rank 4. But here we can see the rank 4 has been skipped and we are getting rank 5. So it as per the rank, it should basically be like 1, 2, 3, 4, and 5. But as there is a tie, which means 21.86 has been repeated, so we can see the rank 4 has been eliminated or skipped. We are having 1, 2, 3, 3, 5. Again 5 is repeated because we have the same total amount here, 18.86 and 18.86. Again the spending rank 6 is eliminated or skipped, and we are moving to 7. Then 8 is also repeated and 9 is skipped. That's how rank works. It leaves a gap when there is a tie. Now let's try the same thing with dense rank. We'll change this rank to dense rank, dense underscore rank, and execute this query. Now we can see the customer ID 6 is having the total as 25.86, and in rank also we are having the same 25.86, and the spending rank is 1. Customer ID 26 is having 23.86 in dense rank and the spending rank is 2. In rank as well, it's the same. The third row, customer ID 46 is having the total as 21.86 and the spending rank is 3. And in the dense rank, it's same as well. In the dense rank, the fourth row is having 45 as the customer ID. Total is 21.86. Spending rank is 3. In the fourth row, in the rank as well, we are having the same thing. In the fifth row, we are having customer ID 7. Total is 18.86. But here, the main thing is there. After 1, 2, and 3 spending rank, we are getting the spending rank as 4. The spending rank 4 here is not getting eliminated or skipped out. Whereas in rank, the spending rank 4 was skipped and we are directly jumping into spending rank 5. But here the case is different. All the ranks are getting retained, but there might be repetitions for each rank if there is a tie. So this is the main difference between rank and dense rank. So even if there is a tie in dense rank, the ranks are getting retained. We are not skipping any particular rank. But here in the rank function, if there is a tie, the function will jump to the next to next rank, skipping the between in between rank. I mean 1, 2, 3, and 4 would be skipped, and we'll be getting 5 here instead of 4. So this is the key difference between rank and dense rank. Now let's move on to the next window function, that is lead and lag. So what are these two window functions exactly? Imagine you are analyzing customer purchases over time, okay? And you want to compare each invoice amount with the previous one to understand did the customer spend more or less this time? Or maybe you want to know about the future purchases or to predict the future purchase of that particular customer. So to understand it better, let's query on our invoice table. Select star from invoice. So here in the invoice table, as we already saw, there are invoice IDs, customer IDs, and the total, which means the total purchase amount of that particular customer based on this invoice. So in a single purchase, how much the customer is spending, the amount the customer is spending. So as I said, you want to compare each invoice amount with the previous one based on each customer. So to understand about the customers' spending trends. Okay. Now let's write this simple query. Select customer ID, comma, invoice date, comma. Let me minimize this Project Explorer window. Invoice date, comma, total. So total we can alias it as total amount spent, comma, lag of total over partition by customer ID. So we are checking the total of each customer. That's why we are doing a partition by customer ID, customer underscore ID. Order by invoice date, as we can give the name as previous invoice or else previous total amount, total amount spent from invoice, order by customer ID, comma, invoice date. Now let's run this query and see what result we are getting. So this query gives you each customer's invoice along with the amount spent last time. So we are using lag of total to fetch the previous invoice total amount or the spent amount, partition by customer ID. So for each customer ID, we can see the previous amount that the particular customer has spent, and order by invoice date. We're doing a order by invoice date just to check the previous date for each customer. Okay. So this is actually helpful for identifying trends like rising or dropping of the spending habits of each customer. So let's get to the first example. Customer ID 1. So the first invoice date was 2022-03-11. So probably the customer has done his first spend on this particular date, and the total amount spent was 3.98. Previous total amount spent is null here because this is his first spend or the first purchase. Next, the particular customer, customer ID 1, did his next purchase on 2022 June 13, 0613, and the amount was 3.96. And for this particular date, the previous amount we can see as 3.98 because for the previous date, his purchase amount was 3.98. Next, he did his third purchase on 2022 September 15th, and the purchase amount was 5.94. Previous purchase amount for this particular date is 3.96, which is the second purchase amount. In the same way, the latest purchase of that particular customer is 2025-08-07, August 7, which is 8.91, and the previous purchase was 13.86. 13.86 he did on 2024 December 7. All right. So this is how we can see the spending habits for each customer. The previous spent amount for each customer on a particular date. Now let's see if we use lead instead of lag, what is happening. Let's execute this query. Let's make it as, instead of previous total amount spent, next total amount spent, because this is the future date, right? Let's re-execute this. Now if we flip the lag with lead, what is happening? You can see the trend is changing, which means this particular column fetches the next row's value. Previously, it was fetching the previous row's value because in lag we can see customer ID 1 on invoice date 2022-03-11. The total amount spent for him is 3.98. So he has spent a total amount of 3.98 on this particular date, and this is the earliest date on which he did any purchase. So prior to this, there is no other purchases made by him. That's why this particular value is null here. But if we see using lead, The next total amount spent is coming as 3.96. So this is the amount which he has spent in the next purchase. I mean in 2022-06-13, which is 3.96. In the same way, for this particular date, June 13, the current amount he is having is 3.96. But the next total amount spent is 5.94, which is for the next date. Next date means 2022-9-15. So this is 5.94 we can see. And on the latest date, 2025-08-07, August 7, the current amount he has spent is 8.91. But the next amount or the next total amount spent is giving us null, because here we can see this is the latest date of his purchase. He has not done any other purchase after this date. So this particular value is null here. But in the lag case, it was different. The first date is having null in this particular column, previous total amount spent. All right. So that is it about window functions. In the description, I will share a link of the database which I am currently using, and you can import the same database in your PostgreSQL instance to practice. So from the link, you can download or copy the SQL code and go here, right click on your Postgres instance, SQL editor, new SQL script, and just paste the whole script here and run it. This will create all the tables and all the schemas on all the relationship that is present in this particular database. These all tables will be created: album, artist, customer, employee, and everything. It will be easier for you to practice. If this video helped you understand SQL window functions just a little better, don't forget to hit that like button and subscribe to this channel, where we break down complex data topics into simple real world tutorials. We have got more coming your way, from SQL deep dives to hands on ETL using tools like Matillion, Postgres, and others. See you in the next video. Thank you.